Dear students, welcome to the study of P block elements. Today we will discuss group number 14 elements. This group is also known as carbon family. This is the third part of P block elements study. In the previous parts we discussed group number 13 elements, boron family. Let us start with the study of group number 14 elements. It's also called as carbon family. The elements present in group number 14 are carbon, silicon, germanium, Sn. It's called as tin. Sn, its Latin word is stannum. Then Pb is called lead. Its Latin word is plumbum. And last one is flerovium. These are the elements present in group number 14. First of all, carbon. Carbon is the widely distributed element in the nature, and it is found in the free state as well as in the combined state in the nature. In a free state, in the elementary state, carbon is known to occur in the form of coal, in the form of charcoal, in the form of graphite, and in the form of diamond. So these coal, coke, charcoal, graphite, diamond, and even fullerenes, these all are elemental state or a free state forms of carbon which is distributed in the nature. Carbon is also found in the combined state. The main forms of the combined state of carbon are metal carbonates, and the carbon is found in the form of hydrocarbons, in the form of organic compounds. Carbon is found in the form of carbon dioxide gas in the air. These are some of the combined forms of carbon element which is distributed in the nature. The carbon has a unique property. Carbon combines with other elements like dihydrogen. Carbon combines with dioxygen. It can combine with chlorine, fluorine, halogens, and it may combines with sulfur. And this combination of carbon with the other elements provides an astonishing array of materials ranging from living tissues to drugs to plastics and many more. Okay, so this is the very peculiar, unique character of carbon. Because of this character, there is a branch of chemistry known as organic chemistry. It is devoted to study of carbon containing compounds, isn't it? Organic chemistry is a very big branch of chemistry which deals with the study of carbon compounds. And this carbon, it's an essential constituent of all living organisms. The living organisms, the humans, the animals, the plants contain carbon in many forms. The food we take is a carbon compound. The proteins is a carbon compound. It's an organic compound. The enzymes, vitamins, the biochemical reactions which are taking place in a biological system, they all are carbon compounds only. Hence, we can call carbon is a essential constituent of all living organisms. Okay. And the naturally occurring carbon, it's found in two stable isotopes. They are carbon 12 and carbon 13. Apart from these two stable isotopes, carbon do found in a third isotope which is found in a very less proportion. The third isotope is carbon 14 and it's a radioactive isotopes. Mainly the use of this carbon 14 radioactive isotope is in a radiocarbon dating. Okay, and this process is used to find the ages of fossils. These are the three isotopes of carbon: carbon 12, carbon 13 and carbon 14. The next element, silicon, it's the second most abundant element in the earth crust. Okay, this concept we studied in a previous group also. Silicon is found around 27.7% by mass of the earth crust. It's a second most abundant element in the earth crust, and this silicon is found in the nature mainly in the form of silica and silicates. Okay, silica and silicates are found in the nature, which are the forms of silicon, and it's an important component. Silicon is found in ceramics. Ceramics allittore, glass contains a silicon in the form of silica and silicates, and even cement contain silicon. These are different forms of silicon in the form of silica and silicates. Germanium, no? The next element, germanium, is exists only in a very trace amount in the nature. The tin, Sn, tin, it's mainly occurs in the form of tin oxide. It's called as cassiterite. Cassiterite is a mineral of a tin, oxide form of a tin. Then lead, Pb, lead occurs in the form of galena, lead sulfide. We call it as a lead sulfide, Pbs or galena. So this is about a brief introduction about the occurrence of group number 14 elements. Now we'll discuss some periodic properties of this group. First one, electronic configuration. The electronic configuration of carbon is 1s2, 2s2, 2p2, or we'll write helium noble gas 2s2, 2p2. Silicon electronic configuration, neon noble gas 3s2, 3p2. Germanium will be argon 3d10, 4s2, 4p2. Tin, krypton 4d10, 5s2, 5p2, and lead will be having the electronic configuration xenon 4f14, 5d10, 6s2, 6p2. Look at the valence shell, last shell, outermost shell. Carbon 2s2, 2p2. Silicon 3s2, 3p2. Next 4s2, 4p2. 5s2, 5p2. 6s2, 6p2. Hakadre, how we are going to write a general valence electronic configuration? It will be ns2np2. That means how many valence electrons are there in a group number 14 elements? 4 valence electrons are there. ns2np2. 4 valence electrons are there. Next property, covalent radius. Look at the trend in a covalent radius of group number 14. Carbon with a 77 picometer, silicon 118 picometer, germanium 122, tin 140, and lead 146 picometer. That means when you move down the group, the covalent radius increases. But when you look at the values clearly, there is considerable increase in covalent radius from carbon to silicon. That means from 77 picometer in carbon to 118 picometer in case of silicon. There is a large difference, considerable increase in the covalent radius. But thereafter, silicon to lead 122, 140 and 146. There is a small increase in a radius is observed, and this is due to what? The presence of completely filled d and f orbitals in a heavier members. Andre, when you move down, the d and f orbital starts filling. There's a little increase in the covalent radius in a heavier members of group number 14. Okay, next one. Ionization enthalpy. Look at the values. Carbon 1086 kilojoules per mole of energy, first ionization enthalpy. Silicon 786, 761, 708, 715. Okay, so there's a gradual decrease in ionization enthalpy except lead. There's a gradual decrease due to increase in atomic radius, increase in covalent radius. The ionization enthalpy decreases down the group. Okay, with the exception of lead here. But you know, The ionization enthalpy of this group 14 members, is quite higher than the corresponding members of group number 13 elements. Physical properties ನೋಡೋದಾದ್ರೆ, all the members of the group carbon, silicon, germanium, tin, lead and lead, they all are solids in nature. The first two members, carbon and silicon, are non-metallic. Germanium is a metalloid, whereas tin and lead are found to be in the form of soft metallic in nature. Oxidation state ಬರೋದಾದ್ರೆ, the valence electronic configuration of this group is ns2np4. How many valence electrons are there? Yes, there are 4 valence electrons, 4 electrons in the outermost shell. Okay, so when both ns2 and np electrons, total 4 electrons, if they take part in a chemical bond formation, the element will exist in the form of +4 oxidation state. If only np2 electrons of the element, if they are involved in a chemical bond formation, then the element will show +2 oxidation state. ಹಾಗಾದ್ರೆ conclusion ಏನು? The common oxidation states exhibited by group number 14 elements is +4 as well as +2. And the compounds which are found to occur in a +4 oxidation state are generally covalent in nature, and those compounds which found in a +2 oxidation states are generally ionic in nature. And when you move down in a heavier members, the tendency to show +2 oxidation state go on increases. ಕೆಳಗಡೆ ಹೋದಾಗೆಲ್ಲ +2 ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಟ್ರೆಂಡ್ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಾ ಹೋಗ್ತದೆ. ಯಾವ ಸೀಕ್ವೆನ್ಸಲ್ಲಿ ನೋಡಿ, ಜರ್ಮ್ಯಾನಿಯಮ್ having lesser tendency than tin than lead, ಅಂದರೆ lead has a more tendency to exhibit +2 than tin than germanium. Why? What's the reason? Heavier members ಕೆಳಗಡೆ ಹೋದಾಗೆಲ್ಲ +2 ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಟ್ರೆಂಡ್ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಾ ಹೋಗ್ತದೆ. +2 ಅಂದ್ರೇನು? Only np2 electrons may involve in a chemical bond formation, not ns2. Why not ns2? It is due to the inability of ns2 electrons of valence shell to participate in bonding. Okay, what's the reason for this? The reason I have told you in the previous classes, in the previous group study of group number 13 ದಲ್ಲಿ ಹೇಳಿದ್ದೇನೆ. ಏನು reason? When you move down, the d and f orbital starts filling, there will be a shielding effect followed by inert pair effect will be there. Due to the inert pair effect, ns2 electrons are not available. They are not available for the chemical bond formation. During chemical reaction, ns2 electrons are not available due to inert pair effect. ಓಕೆ, ಹೆನ್ಸ್ ಯಾವಾಗ ns2 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇನ್ವಾಲ್ವ್ ಆಗೋದಿಲ್ಲ ಅಂತಂದರೆ np2 ಅಷ್ಟೇ ಬಾಂಡ್ ಫಾರ್ಮೇಷನ್ದಲ್ಲಿ ಇನ್ವಾಲ್ವ್ ಆಗ್ತವೆ. ಅವಾಗ +4 ತೋರಿಸೋದಿಲ್ಲ, +2 ತೋರಿಸ್ತವೆ. ದೇರ್ಫೋರ್ ದ ಟೆಂಡೆನ್ಸಿ ಟು ಶೋ +2 ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ increases when you move down the group number 14. Clear? So this what you call shielding effect, inert pair effect, I have told you in detail in my previous class. Howda? Okay, students, there's an instruction. You need to go through these video lectures, understand the concept, and you need to make the notes of this lesson. When you come to the college, I am going to check this P block elements lesson notes. Okay, that's why go through all the parts, part 1 to last video, first video to last video of this lesson. Go through the video, understand the concepts. Okay, then make notes of these points. because I'm going to check the notes in the college. Clear? Okay. And moreover, I'm not putting any PDF notes or anything in the Google Classroom. You need to watch the video. You need to take down the notes. Clear? Okay. Carbon and silicon are mostly found in a +4 oxidation state. Germanium forms +4 as well as +2. Out of that forms +4 compound, many +4 compounds and very few compounds in a +2 states. Tin forms compounds in both again, but +4 two compounds will be the major one, and tin in a +2 state act like a reducing agent. Lead compounds are more stable in a +2 oxidation state. Next point, anomalous behavior of carbon. Okay, again we studied anomalous behavior in the previous class also. In a study of group number 13, anomalous behavior of boron we studied here. Now here we learn anomalous behavior of carbon. The reason for the anomalous behavior, you know what is meant by anomalous behavior. Many times I have told you. In a S block elements I have told you. Even in a group number 13 also. I said you what's anomalous behavior. I'll repeat once again. The property of carbon, most of the property of the carbon are somewhat different from the properties of rest of their members. Okay. What's the reason? Again, when you move down, what happens to the size? Increases. That means carbon has small atomic size, small covalent radius, or the small size. When you move down, ionization enthalpy decreases. We know this concept. Decrease ಆಯಿತು ಅಂತಂದರೆ highest ಎಲ್ಲಿರ್ತದೆ? Definitely in case of carbon has high ionization enthalpy. Down the group, electronegativity decreases. Carbon has high electronegativity and there are no d orbitals in case of carbon element. Silicon ದಲ್ಲಿ d orbitals ಇರ್ತವೆ. Of course they are not filled with electrons, but d orbitals will be there. Germanium ದಿಂದ d orbitals fill ಆಗಿರ್ತವೆ, ಇದ್ದೇ ಇರ್ತವೆ. ಹೌದಾ? ಕಾರ್ಬನ್ ದಲ್ಲಿ d orbitals ಇರೋದಿಲ್ಲ. ಸಿಲಿಕಾನ್, ಜರ್ಮೇನಿಯಂ, ಟಿನ್, ಲೆಡ್ ದಲ್ಲಿ d orbitals ಇರ್ತವೆ. These are the reasons for anomalous behavior of carbon. Okay, then what's anomalous properties? ಯಾವ್ಯಾವುದು? How carbon is somewhat different from the rest of their members. Which are those properties? You know, in carbon only s and p orbitals are available for bonding because there are no d orbitals. ಹೌದಾ? Therefore it can accommodate only 4 pairs of electrons around it. ಹೌದಾ? 4 pairs of electrons, 3 pairs in p orbital and 1 pair in s orbital. Hence, the covalence is maximum 4 in case of carbon. Whereas other members, udella element ಏನು ಮಾಡ್ತವೆ? They can expand their covalency. Why? They contain what? D orbitals. Other members contain d orbitals. Hence, they can expand their covalency. They can show covalency of more than 4 in case of other members. ಹಾಗಾದರೆ ಏನನ್ಬೋದು? ಕಾರ್ಬನ್ ಪ್ರಾಪರ್ಟಿ ಇದೆಲ್ಲ ಎಲಿಮೆಂಟಿಗೆ ಕಂಪೇರ್ ಮಾಡಿದರೆ ಸ್ವಲ್ಪ ಚೇಂಜ್ ಇದೆ. ಇಟ್ಸ್ ಎನ್ ಅನಾಮಲಸ್ ಬಿಹೇವಿಯರ್. ಅಂದರ್ ಪ್ರಾಪರ್ಟಿ ಏನನ್ಬೋದು? ಕಾರ್ಬನ್ has a unique property. It's a unique ability to form multiple bonds, double or triple bond, with itself and with other atoms. Okay, carbon ಒಂದು ಇಂಪಾರ್ಟೆಂಟ್ ಪೆಕ್ಯುಲಿಯರ್ ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ ಪ್ರಾಪರ್ಟಿ ಏನಪ್ಪ ಅಂತಂದರೆ, carbon can form multiple bonds with itself and with other carbon atoms. For example, carbon can form carbon-carbon double bond, carbon forms triple bond with other carbon, even carbon form double bond with oxygen, double bond with sulfur, carbon form triple bond with nitrogen. Andre carbon form multiple bonds with other carbon atoms, or even carbon form multiple bonds with elements like oxygen, sulfur and nitrogen. This kind of character we cannot come across in heavier elements. Heavier elements do not form multiple bonds, okay, because their atomic orbitals are too large to form multiple bonds. Okay, you can see this kind of behavior only in case of carbon. Ikenanbodu anomalous behavior of carbon. These are the reasons and these are some of the properties. Another important anomalous behavior of carbon is catenation. Catenation, just recall your memory. You studied catenation in your lower classes. ಸ್ಕೂಲಲ್ಲಿ ಕಲ್ತಿದ್ದೀರಿ. ಕನ್ನಡ ಮೀಡಿಯಮ್ದವರು ಕೆಟನೀಕರಣ ಅಂತ ಕಲ್ತಿದ್ದೀರಿ. ಹೌದಾ? ಸೊ ಸ್ವಲ್ಪ ನೆನಪು ಮಾಡ್ಕೊಳ್ರಿ, ಏನು ಕಲ್ತಿದ್ದೀರಿ ನೀವು? ವಾಟ್ಸ್ ಕೆಟನೇಷನ್? ಕೆಟನೀಕರಣ ಅಂದರೇನು? ಕೆಟನೇಷನ್ ಇಟ್ಸ್ ಅನ್ ಅನಾಮಲಸ್ ಬಿಹೇವಿಯರ್, ಅಂದರೆ ಕಾರ್ಬನ್ದಲ್ಲಿ ಅಷ್ಟೇ ಕಂಡು ಬರ್ತದೆ. ಏನಪ್ಪಾ ಅದು? Carbon atoms have the tendency to link with other carbon atoms through covalent bonds to form chains, to form rings. This property is called catenation. Carbon has a unique property, unique tendency. To link with other carbon atoms. Carbon mattond carbon jothe bond ಆಗ್ತದೆ, ಅದು ಮತ್ತೊಂದು ಜೊತೆ ಫಾರ್ಮ್ ಆಗ್ತದೆ. Likewise, it form a very long chain of carbon atoms through a strong covalent bonds to form a chains, and even carbon-carbon bonds, they form a rings also, cyclic structures also. This property is called catenation property. ಯಾಕೆ ಕಾರ್ಬನ್ದಲ್ಲಿ ಕಂಡು ಬರ್ತದೆ? ಯಾಕಂತಂದರೆ ಫಸ್ಟ್ ಆಫ್ ಆಲ್ ಕಾರ್ಬನ್ ಬಾಂಡ್ ಈಸ್ ವೆರಿ ಸ್ಟ್ರಾಂಗ್. ಕಾರ್ಬನ್ ಆಟಮ್ ಈಸ್ ವೆರಿ ಸ್ಮಾಲ್, ಸೈಜ್ ಸ್ಮಾಲ್ ಇದೆ. ಕಾರ್ಬನ್ ಆಟಮ್ದು ಸೈಜ್ ಸ್ಮಾಲ್ ಇದೆ. ಕಾರ್ಬನ್ ಬಾಂಡ್ ಏನು ಫಾರ್ಮ್ ಆಗಿದೆ? ಸ್ಟ್ರಾಂಗ್ ಬಾಂಡ್ ಫಾರ್ಮ್ ಆಗಿದೆ. ಆ್ಯಂಡ್ ವೆನ್ ಯು ಗೋ ಡೌನ್, the size go on increases and the electronegativity go on decreases, and thereby tendency to show catenation decreases. ಓಕೆ, ಕೆಳಗಡೆ ಹೋದಂಗೆಲ್ಲ ಕೆಟನೇಷನ್ ಪ್ರಾಪರ್ಟಿ ಕಡಿಮೆ ಆಗ್ತಾ ಹೋಗ್ತದೆ. ಕಾರ್ಬನ್ದಲ್ಲಿ ಮ್ಯಾಕ್ಸಿಮಮ್ ಇದೆ. ಡ್ಯೂ ಟು ವಾಟ್? ಸ್ಮಾಲ್ ಸೈಜ್. ಡ್ಯೂ ಟು ವಾಟ್? ಹೈ electronegativity. And this can be clearly seen from the bond enthalpy values. Bond enthalpy values. The order of catenation decreases in this range. Carbon to silicon, catenation property decreases. Silicon to germanium, ಇನ್ನೂ ಡಿಕ್ರೀಸ್ ಆಗ್ತದೆ. ಅದು ಆಲ್ಮೋಸ್ಟ್ ಈಕ್ವಲ್ ಟು ಟಿನ್ ಇದೆ, SN ಗಿದೆ. ಹೌದಾ? ನೋಡಿ, ಲುಕ್ ಅಟ್ ದಿಸ್ ಟೇಬಲ್. The bond dissociation enthalpy of carbon bond is 348 kilojoules per mole of energy, which is very higher. To break the bond, more energy is needed because the bond is said to be very stronger. When you move down, silicon to silicon 297, germanium to germanium 260. When you move down, the bond enthalpy value go on decreases. Hence, catenation character also go on decreases. Okay, so silicon to silicon bond we will come across, but to a very shorter length. ಕಾರ್ಬನ್ ಚೈನು ಬಹಳ ದೊಡ್ಡದು ಫಾರ್ಮ್ ಮಾಡ್ತದೆ, ಆದರೆ ಸಿಲಿಕಾನ್ ಬಾಂಡ್ ಇರ್ತದೆ, ಆದರೆ ಬಹಳ ಸಣ್ಣದಿರ್ತದೆ. ಯಾಕೆ? ಬಾಂಡ್ ಎಂಥಾಲ್ಪಿ ವ್ಯಾಲ್ಯೂ ಕಡಿಮೆ ಇರೋದ್ರಿಂದ ಬಾಂಡ್ ಅಷ್ಟು ಸ್ಟ್ರಾಂಗ್ ಇರೋದಿಲ್ಲ. ಜರ್ಮ್ಯಾನಿಯಮ್ ಟು ಜರ್ಮ್ಯಾನಿಯಮ್ ಬಹಳ ಕಡಿಮೆ, ಬರೀ ಒಂದೇ 2-3 ಎಲಿಮೆಂಟ್ಗೆ ಅಷ್ಟೇ ಇರ್ತದೆ. Whereas lead do not show catenation property. Okay, so idu catenation is also an anomalous behavior. Okay, so this is about today's class. We discussed carbon 14, carbon family, group number 14, their occurrence, few periodic properties, very few physical properties, oxidation states, and anomalous behavior of carbon element. ಹೌದಾ? Along with that, we discussed catenation property. In the next class, I'll continue with the same group. We will study a very important concept, allotropic forms of carbon. In the next class, we are going to study about diamond, graphite and fullerenes, which are the different allotropic forms of carbon. Okay, so with this I'll conclude today's class. Watch the video, understand the concepts, make notes, okay, then share this video to your friends. Thank you.